Okay, so we've been solving quadratics by factoring earlier in this module in the first couple of lessons. And unfortunately, it doesn't always work, right? There are many, many quadratic equations that exist that just are not factorable. There aren't any, the combination of coefficients just don't work. Maybe we have some decimals or fractions in there that makes the factoring difficult. So we need a way to solve those equations, okay? And so that's what the quadratic formula does. The quadratic formula is a formula that lets us solve any quadratic equation. We're going to put it into standard form. So for quadratic equation in the form of ax squared plus bx plus c equals 0, we are going to plug right into this formula. X equals the opposite of b plus or minus big square root of b squared minus 4ac all over 2a. Now this is something that you're going to want to remember going forward. You'll need it for your next class. It's something that you'll probably want to memorize if possible. And the good news is there's a lot of memory aids out there available to you. Like I think that there's, if you go to YouTube and you put the quadratic formula song into YouTube, you're going to get a lot of different options. I'm not going to sing, but a lot of people will sing for you. So there's a Pop Goes the Weasel version that's very common and kind of classic. There's a Gilligan's Island theme song. If you're a little older like me, you might remember that show. There's an Adele song that someone's done that's pretty nice. So there's a lot of tools out there that are available to you to help you remember this quadratic formula. And you'll want to remember it. It's something that you'll need for your next class probably, and it's something it's handy to know. Okay, so let's look at how we use the quadratic formula. Now, this is an example problem where we don't have to use the quadratic formula. In fact, I'm going to solve this real quickly without using the quadratic formula because I would not recommend using the quadratic formula for this in general. This is one that if we can factor, it's quicker and easier to solve this with factoring. And so if I try to factor this, it's in the standard form, got the 0 on one side that we want. I'm going to set up my x just like we have been doing. I'm going to look for two numbers that multiply to give me 3 and add to give me 4. Okay, so 3 times 1 is 3. Positive 3 plus positive 1 is 4. So I can get everything that I want to work out there in my x. Okay, and then I can break this down, put in these values, plus 3 and the plus 1 for my x over there. Set each of those factors equal to 0 separately. And then solve. And get my answers. And this is certainly what I would recommend doing for this problem if you were just asked to solve it. Factoring is quick and works nicely once you've got this down, and it's something you should get down. It's something that you'll see again and will be part of your test. Okay, but the quadratic formula does work, and it's easiest for simple problems like this. So let's start. Let's do it with the quadratic formula. See if we can get the same answers. Okay, so if I want to solve the same problem with the quadratic formula, the first thing I'm going to think about are what are my a and b and c values. Those are just the coefficients of each of our terms. So my a is 1. My b is 4, and my c is 3 for this particular equation, okay? And so I'm going to plug into my formula. Again, I would recommend writing this down a bunch of times because you're going to want to remember it. Okay, and then we're going to plug into the formula. So my b is 4. I want the opposite of b. Make sure you put this on the top of your fraction bar. It's a pretty common mistake to not have that fraction bar going far enough across, and that can get you the wrong answer, especially if you're going to use your calculator for some of the calculations here. So up top, I'll have a negative 4 plus or minus big square root b squared minus 4 times a is 1 times c is 3, all over 2 times a, which is 1. Okay? So now we need to do this calculation, and I would recommend starting in here And there's a couple of ways we could do this. You can, work it out by hand if you want, but really there's nothing wrong with just saying 4 squared minus 4 times 1 times 3 and putting that into your calculator. And if you do that, you're going to get 16 minus 12, or 4, there. Okay, and then we know what the square root of 4 is. That's 2. Right? And so we've got this plus or minus in here. We haven't seen a lot of that in this class so far, but really what that means is that there's 2 separate answers here, one for the plus and one for the minus. So we just want to kind of break that up and do 2 separate kind of mini problems here. Negative 4 plus 2, and then negative 4 minus 2 over 2. We just want to do each of those calculations separately to get our final answers. So negative 2 over 2 gives us negative 1 for our first one, and then here negative 6 gives us negative 3. Okay, so negative 1 and negative 3 are going to be our 2 answers here. And that's the same thing we got when we did this problem by factoring on the last slide. Okay, so just showing you that this will certainly work on problems that are factorable, but in general, you notice how much less work and effort we had to put in to solve this thing by factoring. We factor when we can because it's easier, but the quadratic formula is very powerful because it works for all problems. Okay, so let's do another one that factoring doesn't help us with. So if we're looking at a problem like this, the first thing that has to jump out at you about this problem is that it is not in standard form. We don't have a 0 on one side. Okay, we saw that when we were solving the quadratics with factoring. We need that 0 on one side. So our first step here is to move all this stuff over. I would recommend moving everything over onto the left side. I personally like my x squared term to be positive whenever possible. So I'm just going to move this stuff on over and get my 0 on one side. Okay, and so once I get to this point, I can read my A and B and C and figure out what my values are. Now, you might try to factor for a second in a problem like this, but it's just not going to happen. There are not 2 numbers that multiply to give you negative 3 and add to give you negative 5, right? There's just isn't going to happen. So this is why we have to have the quadratic formula exactly for problems like this. So we're going to get our values. So my A is 1, my B is negative 5, and my C is negative 3. Okay, and so we plug into our formula here. So we want the opposite of B. So the opposite of negative 5 is 5, plus or minus B squared. Now make sure when you're putting this in, you're squaring the whole thing. So you want to put it in parentheses, especially if you're going to use your calculator. Those parentheses are not optional. If you just write negative 5 squared with no parentheses, put it in your calculator, it's going to calculate that as negative 25, and that is not correct. So you want to make sure you're putting that negative 5 in parentheses. So 4 times A is 1 times C is negative 3. I think the safest way to do this is just to always put those values in parentheses, especially if you're going to use your calculator, which I do recommend for this. Okay, so then our next step is to put this stuff in your calculator, the negative 5 squared minus 4 times 1 times negative 3. Put it in your calculator, just the inside of the radical, okay, and do it all in one step. And if you do, negative 5 squared minus 4 times 1 times negative 3 with all those parentheses, just like we have them written on the paper there, 25 plus 12 is 37 is what you'll come up with there. Okay, and we are done with this problem at this point. The square root of 37 is not a nice number that's going to come out evenly for us. Okay, I guess you do want to read your instructions in problems like this, because usually we'll just want the exact value, and that's what we're looking at here. This is the exact value, the best we can come up with, but sometimes you'll be asked for a decimal approximation instead. If you're asked for that, then you would just put 5 plus the square root of 37 over 2 into your calculator, and 5 minus the square root of 37 over 2 in your calculator and just kind of get decimals for those instead. This question wants the exact value, and so we're just done here. We just want this exact value, and we're finished. Do look for the word approximation. Sometimes you'll be asked for that instead. Okay, so the last little topic to discuss in lesson 5 are these problems that have some x squareds in them that we want to solve. And I think most people would look at this and say, oh yeah, the answer to this is 5 because, well, 5 squared is equal to 25. We multiply 5 times itself, we get 25. And you're not wrong. That is an answer, but there's actually more than one. If you think about the number -5, we plug that into this equation too. -5 squared, -5 times -5 is also positive 25. So this is a trickier question than it looks like because there are 2 correct answers to this thing. And we're going to use this idea called the square root property to solve this problem. We saw it, kind of the reverse of this in the last lesson when we were solving radical equations. When we wanted to get rid of a radical in our radical equation, we squared both sides, right? And then we had to check our answer. So we had kind of a little curveball there. Similar here, we have a little curveball. If we want to solve these x squared equations like this, we can solve them by taking the square root of both sides. Like the square root of x squared is equal to the square root of 25, but not just the square root of 25. It is plus or minus the square root of 25 because we want to get both of those answers that are going to solve this equation. Okay, so over here on the left, the square root and the square root are going to cancel each other off. Leave us with an x, and then the square root of 25 is 5. That'll give us both of those answers that we need. So when we're trying to solve an equation, if it has an x squared in it like this, we want to use the square root of both sides to get that to work out. We need to put a plus or minus on the other side of the equation in order to get all of our possible answers. Okay, so we can use this square root property to solve equations like this. If we want to do that, the first thing that we want to do here is we want to get that z squared onto one side by itself. So my first step here is going to be to move this 16 over to the other side, get rid of these. And then over here, we'll just add these up. And then we're not ready to take the square root of both sides yet. We want to get that z squared by itself first. So we want to divide by 4. Get that z squared completely by itself first. And now we can take the square root of both sides. Don't forget, when we take the square root of both sides using the square root property, we need to put this plus or minus in here to make sure we're taking that into account. And then that square root and that square will cancel each other off, leave us with the z by itself that we want. And we'll get 2 answers to this problem, 2 and -2, because of that plus or minus that we need to put in when we take the square root of both sides of equations like this. Okay, so hopefully that's enough to get you off to a decent start on this. Please let me know if you have any questions. Contact me through Ask My Instructor. Let me know what I can do to help.